Lecture 24th, the Riemann tensor and holonomy. In general, holonomy refers to how much a vector changes when you parallel transport around a closed loop on a manifold. If the manifold is flat, transportation around any loop brings the vector back unchanged. That's why the holonomy is important. Now, on the other hand, if the manifold is curved, transporting around the loop rotates or transforms the vector. Let's show that. You see, the change of a vector v, okay, is minus this here. That's what we derived in previous lecture. You see, now this v sigma dx mu dx nu. That's holonomy. So first, the path around the infinitesimal parallelogram. Okay, this is the parallelogram A, B, C, D. You see, is counterclockwise. Now, A to B, you see the distance, that infinitesimal distance, is dx mu, B is dx nu, C minus dx mu, D to A minus dx nu. You see this figure over here. Now walk from A to A and obtain this change in the vector v over here. You see? Now I would like to say that the math involved here is algebraic. It's quite easy. You see, just to pick a piece of paper and try, okay, to follow what I'm doing here. You see, because I skipped, okay, some substitution, as you can see. Now, recall the parallel transport equation along the displacement dx lambda in general. You see, this is v whole x plus dx, v whole x minus, this is Christoffel symbols, okay, at x, okay, that's the v sigma at x dx lambda. This in general will be this will be applied to this case over here, in which d lambda, okay, this is dx nu minus dx nu dx mu, this 4. So first, transport from A to B. You see, I transport from A to B. The distance is dx mu. You see, I just substitute here VB, VA minus, okay, this Christoffel symbol at A, VA dx mu, displacement dx mu. You just see the figure. Now from B to C. Now here you have to pay attention, okay, because from B to C, okay, B to C, I already used once the Christoffel symbols. So this here, Christoffel symbols, I just used here the Taylor series, okay? This Christoffel symbol at B, Christoffel symbol at A, plus the first derivative, partial derivative, okay, of the Christoffel symbol, dx mu. See here, I neglect the order terms on the Taylor series. So the vector transport from B to C, in this case, is, you see, I substitute, okay, just clearly, okay, this Christoffel symbol here, just over here. It's quite easy. You see the colors over here. You see, the blue one and the green one we use later. So substituting, you see, then this and neglect higher order terms in the Taylor series, the expression, okay, after two edges, you see two edges, 1 and 2, okay, AB and BC. You see, this is obtained. I just substitute, you see. I didn't write here, okay. I just substitute on your paper, okay, that's clear. Now, this term 3, transport from C to D. You see, from C to D, okay, the displacement is minus dx mu. You see, so again here, okay, I have to pay attention, because then first, okay, I set the Taylor series, okay, from B to C, from C to D. See, this is at A plus, in this case, the Christoffel symbols, just clear, okay? So this, sorry, I think this is D, okay? C to D. This is C over here. See, there's a Taylor series from C to D, displacement minus dx mu. Again, okay, this formula, okay, this is the parallel transport, okay, from C to D. I just, you see, there's a general, and now here is particular, when the displacement is minus dx mu. Now we can separate, okay, this here. You just copy on your paper, okay, and check all this. Number 4, okay, now the green one is just this green one here, okay? I just substitute over here. It's quite easy to see it, this algebra, okay? Now, term 4, transport from G to A. D to A, okay, you see here, D to A, the displacement is minus dx nu. So, dx nu, then, again, D to A, okay, I use the general relation over here, just over here. So, now, then here, if I substitute, you see, I collect all the terms. This match exactly. This is a curvature, okay, which we derived in previous lecture, okay. So that I wrote just over here, okay. This one I derived, okay, using the abstract definition and the standard definition. I just here to confirm, okay. Now this geometric, you play here with geometric parallelogram over here. That's it.